we use the power function to discuss the end behavior. What is the end behavior? End behavior discusses the change of y as x increases or as x decreases. That is to say, in the Cartesian plane, for example, for this graph, x increases. For this point, this is x1, this is y1. Next time, this is x2, this is y2. We say, from this point A to this point B, x increases. We want to know the change of y. Here, y1 changes to y2. Obviously, y also increases. This discussion is so-called end behavior. The next situation, for example, if for this graph, from A to B, x increases, but y for A changes to y for B. You can find out y coordinate of B less than y coordinate of A. So we say x increases, y decreases. This is so-called end behavior. X decreases. For this situation, if the graph is here, we say from point A to point B, x decreases. What is the change of y? Ya is here, yb is here. Obviously, y increases. So we say x increases, y decreases. X decreases, y increases. This is the end behavior of this graph. For this situation, if x of point A is here, this is xa, this is xb, xa changes to xb, this is so-called x decreases. What about yb and ya? You know, yb less than ya, so we say x decreases, y also decreases. So you need to know, we discuss end behavior with the prerequisite that x increases or x decreases. We want to know with these prerequisites, what about the change of y? All right? For the power function, the end behavior discussion is simple. For example, this is the cubic function, this is the quadratic function. This function, you know, its graph should be like this. Here, in the Cartesian plane, you know, the graph should be like this. All right, you can use several key points to locate this graph. Okay, we say this graph is located in quadrant 1 and quadrant 3. For this part, if x increases, y also increases. We say for this point and this point, you can find out x increases, y also increases. For this part, all right, from this point to this point, x decreases. This y coordinate less than this y coordinate. That will say x decreases, y decreases. All right? Especially, we can describe this situation more accurately. That will say x decreases. We can say x approaches negative infinity, y will approach negative infinity. For this graph, x approaches the positive infinity, y approaches positive infinity. All right. Now, if this function is y equals negative x raised to 3, you can figure out its graph easily. You just need to flip the graph over x-axis. All right. So the graph should be like this. All right. In this situation, you know, for this graph, for this part, x increases, y decreases. This is the end behavior of this power function. So this power function. For this branch, x decreases, y increases. So we say x decreases, y increases. Alternatively, we can say x approaches to negative infinity, y approaches to positive infinity. Okay, next, for this function, y equals x raised to 2, and y equals negative x raised to 2, all right? In the Cartesian plane, you know, this is y equals x raised to 2. This is y equals negative x raised to 2. For this function, for this branch, x approaches to positive infinity, y approaches to positive infinity. We can say x increases, y increases. For this branch, x decreases, y increases. So we say x approaches to negative infinity, y approaches to positive infinity. For this function, x approaches to positive infinity, y approaches to negative infinity. X increases, y decreases. For this branch, x approaches to negative infinity, or we say x decreases, y also decreases, or we say y approaches to negative infinity. In fact, we can find out for this function, y equals x raised to 2, if this exponent, that is to say this n, this n is an even number, we find out the property of the graph. You will find out the graph of this function itself is symmetrical over y-axis. We say this is line symmetry. All right. For the previous function, that is to say this function, its graph is here. All right. That is to say, if this exponent, this n, is an odd number, this function, its graph itself, is symmetrical over or about the origin. That is to say, this point A, you can find out its symmetrical point about the origin. That is A prime. We say this is point symmetry. Of course, we will discuss this question deeply in the future. You just need to know for this function, if this exponent is an even number, it will be symmetrical over the y-axis. If this number is an odd number, its graph will be symmetrical over or about the origin.